Hello and welcome to a lesson on artificial intelligence. In this lesson, we are going to look at a relatively new area in AI called Generative Adversarial Networks, or GANs for short, and we will try to answer the question, can AI create art? Now, before we get into the AI portion of it, we'll try to answer the question, what is creativity? We generally consider creativity as being able to create something new you based on your experience, as opposed to selecting something that you have already seen or heard. Basically, creating a new pattern as opposed to repeating a pattern that you have already experienced. So, do you think an AI can be creative, or do you think that an AI can learn to create art? Traditionally, when we look at the artificial intelligence landscape, the answer to those questions was no. But now we are not so sure. Why? Because if you look at the background, all those images you see, all of those were created by an AI. So the definition of an creativity is little bit blurred, right? For us humans, the motivation for creativity can come from many places, but sometimes, so most of the time, for many of us, the greatest motivation to become creative is having an adversary. Now, what's an adversary? It's someone or something that is standing against you, or at least what you think is standing against you. Someone who says you can't do something. So, we've all experienced a sense of creativity in such situations, right? So, let's look at a story that shows a situation like that. There was once a novice artist. Now, this artist wants to become like a great artist that were before him. So, this artist starts learning to create artwork by taking inspiration from artwork by those existing artists. Now, this artist creates a piece of art and shows it to an art critic. This critic analyzes this artwork, and because it's a very first attempt of the artist, the critic declares it as not good enough. But the critic wants to help the artist as well. So, being a good critic, the critic provides very detailed feedback to the artist on why the critic think that piece of artwork isn't good enough. The artist takes in all those feedback, tries to improve his work, and creates another artwork with changes based on the feedback and shows it back to the art critic. Now, again, this second attempt is also deemed not good enough. And again, the critic provides feedback to the artist, and the artist starts working again. Now, this happens over several cycles. Every time the critic criticizes the artwork, the artist gains experience on how to improve it. And likewise, every time the artist generates a new piece of artwork, the critic also gains experience on how to evaluate it. Now, after many such iterations, Finally, the artist creates a artwork which the critic considers to be a masterpiece. Now, if we look at this story, the artist became a master finally because of the critic. It is because of the feedback given by the critic as well as the act of determining that the piece of artwork is not good enough that motivated the artist to master his craft. Now, can we do something similar to an AI? And that is the idea behind generative adversarial networks. Generative adversarial networks, commonly shortened as GANs. GANs are a machine learning model where two neural networks contest with each other to generate new data with the same characteristics of a given training set. We call it generative because this model generates new data as opposed to picking the output from a given training set. And we call it adversarial because there are two networks and the two networks works as adversaries of each other. They basically compete against each other. And it's a network because this model is also based on the same concept as neural networks. Now, this is what a typical GAN would look like. We have the two networks, the generator and the discriminator. The generator is our artist and the discriminator is our art critic. The generator generates a set of items and the discriminator who has access to a set of training set with real world items takes in the generated items as input and try to determine whether they are real or fake. And after each classification, both the generator and the discriminator gets retrained. The generator or the artist does not get access to the real world item set. Usually, random noise vector is used as a starting point of a generator. The discriminator does have the access to the real item set, which it trains on to become expert at telling the generated and real items apart. In a GAN or a generative adversarial network, the two networks, the generator and the discriminator, are trained together. The generator will become progressively better at generating items that will look real, and at the same time, the discriminator will become better at telling them apart. After many iterations of this classification and retraining, there will come a point where the discriminator may not be able to distinguish the generated items from real ones. And at that point, the generated items will be, even for humans, will probably be indistinguishable from the real ones. Now, we say these as generated items. Now, these items, as we call them, can be images, text, videos, sound, music, or anything. It's up to whoever trains this network, this model, to decide on what they want to generate. As I said earlier, the generator typically takes a random noise vector as input, and the discriminator takes a set of real-world objects belonging to the class that you want to generate the objects on. For example, if you want to generate certain types of image, and the discriminator will need to have access to a training set of those same category of images. Let's take an example of a GAND. Let's say we want to generate a set of images resembling handwritten digits. So we need to start with a training set that is used by the discriminator to learn about actual or real world examples of handwritten digits. And the generator will start with a random noise vector and generating these similar looking images, and progressively becoming better and better at generating images that resemble actual handwritten digits. So at the start, or at the first iteration, what's being generated by the generator will probably look like just noise. And the discriminator will have no problem of classifying them as fake images. Few iterations later, we would probably see some sort of shapes, recognizable shapes being generated by the generator, and still at that point also the discriminator will probably be able to classify them as fake images. But after many hundreds of iterations, many iterations later, there will come a point that the discriminator will not be able to identify that the images that is fed to it are generated images, and at that point it may start classifying them as real images. So the goal of the generator will be to at one point start generating images that are indistinguishable from the real ones. So let's see what sort of a code we can use to train such a GAN model. Now, in this one, as I mentioned, we are going to generate handwritten digits, and we will use the popular MNIST dataset as our input. Now, first, our generator. Now, this is, if you go through this code, you will recognize this as sort of similar to a neural network, but flipped around. So we start with a flat noise vector as the input that goes into a dense layer, and progressively the network will upsample it. So we use convolutional 2D transpose layers or upsampling layers to take that initial input vector and transform it to a square image, and in this case it's 28 by 28 pixel image. The discriminator is again a neural network, and this time it's exactly similar to the neural network models that we are used to. So it takes the 28 by 28 pixel input image and basically downsample it to a dense layer, which outputs a single 1 or 0 depicting either it's real or fake. Basically, that is the classification layer of this discriminator model. And the most important part of any GAN is the feedback phase. Now, if you think back to our story of the artist and the art critic, you know that the artist only started to get improved results because the critic actually provided feedback to the artist. Likewise, for our generator, the artist in this model, to become better at generating images, there needs to be some sort of a feedback given back to it after generating each batch of images and classifying them with the discriminator. So we, in this case, we take the loss values and basically apply those loss values to the gradients of the two networks to train them for the next iteration. So little by little, using the loss values and applying them to the gradients, we nudge the two networks to becoming better at doing what they are meant to do. So for the training, it's fairly straightforward. We take our data set, we divide it into training batches of images, and one batch at a time is passed to the training step of the two networks, which after each step, the feedback phase will also run, and we do it for the number of epochs that the training is configured for. Now, this sort of training, especially GANs in general, takes a lot of time to generate, and it would require many hundreds of iterations of training to get some favorable results. And here you can see results of one such run with hundreds of iterations, and this took several hours in a moderate desktop machine. So how did our results look? So as expected at the iteration 1, the results are basically a set of noise vectors, so noise images. After about 100 iterations, we can see some recognizable shapes being formed by the test images. After 200 iterations, the shapes are a little bit more defined, but still, even for humans, we can identify these as not human-generated ones. But after 1,000 iterations, then these are looking really like they were generated by a human, and even both the machine or an unsuspecting human will definitely categorize these as human-like or human-written digits. But these are machine-generated images that are indistinguishable from human handwritten. So you can see that even with a relatively small model with relatively small amount of code, the GAN we created was able to generate surprisingly realistic handwritten digits that even a human can't tell apart. So our simple example GAN was able to give some impressive results, but what more can GANs do? Can they do something more complex? What about generating human faces? So this was an attempt at trying to generate human face images using the same model that the same code that we used for our earlier example, just with a little bit more deeper and larger two neural networks for the generator and the discriminator. So here you can see this is after 1000 iterations, and the model was able to start generating some images that resemble human faces somewhat, but still they are not realistic looking. So can we do better? Do you think GAN can generate human-like faces like this? And do you see anything unique about these faces that is displayed here right now? Well, you should, because none of these faces are real. All three of these images were generated by a GAN. All these images that you see here, all these faces, this was generated by a GAN created by NVIDIA. And you can actually go to this website called thispersondoesnotexist.com, and you can see the GAN model by NVIDIA generating very realistic, photorealistic actually, human faces in real time every time you refresh the page. So now I hope you can see how powerful this GAN concept can be. So what are the types of GANs out there? The code that we looked at is one of the most simplest versions of GAN called DCGAN, or Deep Convolutional Generative Adversarial Networks. There are many other forms of GAN implementations, such as CycleGAN, StyleGAN, Conditional GAN, and many more. So models like CycleGAN can basically translate image from one domain to another domain. So you can see an example here. You can see that this GAN was able to convert the horses in this one image into zebras in the other. Likewise, CycleGANs can change the domain of an image and make it make a new image in another subject area. And they can do things like this. This is called a neural style transfer. So you can see the top images are the input of the GAN model, and you can see a realistic image as our main input, and an image that has the style we would like to apply to that image. The GAN is able to take the objects and the outlines from the main image, take the styling information from the second, and combine them and create a new image which has the objects of the first but the style of the second. Now this sort of model, although we call it neural style transfer, is not limited to an artistic images like you see here. So what else can it do? It can do things like this as well. So here you can see a set of source images of different people, and the style of those people's faces were extracted out and applied to a set of other images of different people, and the resulting images look like totally different set of people with the same characteristics of one set of images. So again, I think you can see how much potential this technology has. And here's a pretty cool demo by, again, a project by NVIDIA. It's called the GoGAN model. It allows you to create realistic looking photographs or artwork just by giving a very rough outline of what you need. So you can basically draw a landscape that you would like to generate with few lines of drawing, and the GAN network is able to generate a photorealistic image of that landscape that you would like to see. Basically, with a model like this, anyone can be their own artist. As discussed earlier, the capabilities of generative adversarial networks are not limited to images. So here we can see a result of a model called GPT2, which is built by OpenAI, that is able to generate text based on the same concepts of GANs. So the GPT2 model is able to take in a very short description given by a human and turn it into a large sets of text or paragraphs that discuss of the same subject area in the early the example summary given by human. And it's not limited to text also. Again, a project by OpenAI called the OpenAI Jokebox is able to generate music, and not only music. These include lyrics and both lyrics and music generated by the GAN models as well. You can check out several samples at openai.com through this link, and everything you see there is generated by a GAN concept model. Now, with all these capabilities of generative adversarial networks, there are certain dangers as well. One area is you can now generate real looking photos and videos that has the potential to create many social problems. So you can basically alter a video to have any person that you like saying anything that you feel like. So it's a danger to the society, but again, certain research institutions are working on creating more models using the GAN concept again, that is able to distinguish GAN generated media from the actual ones. So the answer to the dangers of GANs is GANs themselves. So I hope you see the potential in this relatively new field of AI. The idea of GANs only started becoming more popular in the last 2 or so years, and we are only seeing some of its capabilities still. There are much more research being done on this area. And if you have any questions, feel free to contact me through the email address given below.